Hola.
Good morning.
Good morning, Mr. P.
There we go. You guys are a lot more live than say a word. I know. You guys ready for first period?
LA.
Science.
Science.
Are you guys quiet first period?
Yeah.
Nope. No.
Yeah.
You guys are a lot more live. First period in math is pretty quiet. All right. What you guys do is read through that scale factor table that we wrote there. The scale factor of the dilation is between 0 and 1. Basically, it means it's smaller than 1. What's true about the dilated figure?
Smaller than the original?
Exactly. It's smaller than the original. We haven't done this yet, but I think you're all smart enough to figure this out. What if we dilate something by a factor of 1?
It's the same size as the original.
We haven't changed it. You multiply by 1, it's the same. Billy can read well. It's the same size as the original. Okay? What if you dilate something by a factor greater than 1?
It's bigger.
Larger than the original. Okay? So all makes sense. That's nothing new. All right. Yesterday we learned that two figures are similar if they have the same shape but different sizes, and the sizes of the two figures are related to the factor of the, what goes in that blank? Somebody?
Ratio.
The second one's ratio. Good try though.
Dimension.
Dilation. Haha, I knew that. So the figures are related to the scale factor of the dilation, which, when things are getting bigger or smaller, we're talking about dilations. And then, Harrison, what did we use yesterday to determine if they're ratios? Okay.
Billy.
Ratios are just a fancy word for a fractions. So you're going to be setting up a lot of fractions today. And you're going to decide if things are similar or not. And then actually by setting up that ratio, you actually found the scale factor yesterday. I don't even know if you guys know that.
Thanks.
All right. Now, what happens if you know the scale factor and you know the dimensions of the original figure? Okay? How could you get the dimensions of the new figure?
Multiply the dimensions by the scale factor.
Well said. Multiply. Trace gets an A for the day.
Good job, Trace.
Multiply the original dimensions, big words, by the scale factor. And that's all we're going to do today. I don't think it's going to be anything new. I don't think it's going to be anything tricky today. All right?
Wait, what?
How did I get to page 2 already? All right, here we go. Changed on us. Who would like to read us example 1 loud and proud? Who likes to read? Go ahead, Minetti, give it a shot.
Rocco is creating a scrapbook of his family. A photo of his grandmother measures 3 by 5 inches. He enlarges it by a scale factor of 4.5 to place in the scrapbook. What are the dimensions of the new photo? Is it proportional to the original photo?
Okay? All right. Here's what I want you guys to do. It doesn't have to be perfect. Everybody draw a rectangle that is and label it 3 by 5. There's the original. And it took you guys 1 second to do that. It didn't take long. Here's the original photo of Grandma. Okay? You can put a picture of Grandma in there if you want. There's Grandma. She's got nice
Got the
long.
wrinkles.
Okay. There's Grandma. He needs it to enlarge it by 1.5. Trace, what would you do to the numbers to make it 1.5 bigger?
Multiply them by 1.5.
Which one?
5 and 3.
Yeah, both of them. Very good. Everybody grab your calculator, multiply by 1.5. What are the new dimensions of the photo of Grandma? Grandma Mom. Miss Angie, what do you think?
4.5 by 7.
Great. 4.5 by 7.5. So I'm gonna. That's one of my answers. What are the dimensions of the new photo? 4.5. All right, 4.4. 4.5 by 7.5. And then, is it proportional to the original photo? I don't think we talked about proportions yesterday, did we? Is anybody smart enough to remember what a proportion is from last year? You guys know, believe it or not. I'll tell you guys what it is. What do you remember? Right, it's 2 ratios that are equal. Okay? So what I'm going to do is I'm going to go 3 over 5. The original short side over the original long side. You could have done 5 over 3. It really doesn't matter. is that the same as who can match up the 3 and the 5 with the big one with the right numbers? What does that have to be equal to? Matthew?
4.5 over 7.5.
Nice. So, you just made a ratio, or you just made a proportion. Two ratios that we think, we're going to see if these are equal. Does anyone remember how to tell if that's true or not? There's a couple ways to do it. Right, cross multiply. Everybody grab your calculators and multiply diagonally. And some teachers actually teach it like this. They circle diagonally.
Wait, couldn't you just do 3 over 7.5 and then 4.5 over?
I don't think you can do that because the 3 does not go with the 7.5.
Then why are you multiplying?
Well, because that's what's true about ratio or proportions, Harrison. Good question. In a proportion, cross products are equal. So, did anybody multiply? Are they the same numbers?
Yeah.
Yeah. So, yes, this is proportional. Which I think is really stupid that they ask you is it proportional because whenever you dilate something with a scale factor, it is always proportional at the end. So, well, I think you got to check it. I've tried to think of an example where if you dilated something, it's not proportional. I couldn't figure one out. So they're always going to be proportional.
What if you multiply by a negative number?
Then you would get negative dimensions, which is impossible. Good question, Harrison. And that's why, Harrison, look back up at the top.
So you're saying
Scale factor's got to be between 0 and 1, equal to 1, or greater than. It's never negative.
So you're saying every problem in our homework is going to be proportional?
I think so.
Then what's the point?
Wait. Only if you're multiplying by a scale factor to
Yeah.
enlarge or reduce something. Yes. I think that's true. I think that's a true statement, Bill. So, hey, let's try another one of these. All right, Miss Thielen enlarged a photo of her dog. Miss Thielen is really into her dog, by the way. Talks about her dog. She loves her dog. Miss Thielen enlarged a photo of her dog by a scale factor of 2 for her web page. Especially if you're putting pictures of your dog on the web, that's got some issues. No, I'm just kidding. We have 2 dogs. So I guess we.
What's the new one's name?
Dexter, who used to be Miss S's dog.
Oh.
They
You gotta take care of it.
and they found him on the side of the road, nursed him back to health, and now we have him, and he's a pain in the you know what.
What's the
Saturn.
other one's name?
What's that?
What's the older one or whatever?
Rocky. We have Rocky and Dexter.
No more Rocco.
No.
Rocco's his buddy from
Now
college.
Rocco's my buddy from college. Rocky's my dog. And Dexter's our dog. Oh, Dexter's a good dog, actually. All right, so Miss Thielen took a photo of her dog and did a scale factor of 2 for her web page. She then enlarged the web page photo by 1 point. So she went this, and then she went that. Okay, so she did it twice to print it. If the original is 2 by 3, what are the dimensions of the print? Are the enlarged photos similar to the original? All right, do a small rectangle, guys, because it's only 2 by 3. There's the original picture of Miss Thielen's dog. Okay? Her dog looks a lot better than that. Okay?
Oh my god.
I gotta put a tail on. Bad tail. All right. What did she do first to the photo?
Enlarged it.
By how much?
1.5.
I think that's the 1.5 was second. So 2. So multiply the dimensions by 2. Hopefully you can do that without a calculator. We are actually making it twice as big. Think about it. Okay. What are the dimensions of the enlarged photo? Choose go.
4 by 6.
4 by 6. Very good. Right spot. But then let's make our dog a little bit bigger. That's actually a pretty good dog, people. I don't know what you're complaining about.
Where are the ears?
Where are the ears?
Right there. Kind of looks like his eye. All right. Now, she wants to take that photo and put a scale factor of 1.5. Is it going to get even bigger now?
Yeah.
Yeah, 1.5 is more than 1, so make it a little bit bigger. And what are we going to multiply the middle picture's numbers by? Yeah, now you can do either use your calculator, or I think multiplying even numbers by 1.5. Try to do it in your head. Do you guys know how to multiply
9.
even numbers by 1.5 in your head?
Yeah.
6 and 9.
What's 1 of 6?
3.
No, what's 1 whole of 6?
1.
What's half of 6?
3.
Add them together.
4.
6 plus 3 is not 4, Bill.
You said 3 plus 1. That's all I meant.
No, I meant the 6 plus the 3
Yeah.
is 9. Try to do 4.5 times 1. 4 times 1.5 in your head.
6.
6. Very good. So, bigger dog. That was a bad dog.
That's tears.
Okay, so there's a picture of his dog. And then what are the dimensions of the print? So you would say 9 by 6. Could you say 6 by 9?
Yeah.
Sure, the order of the dimensions does not matter. Okay? And then, watch how this stuff's proportional. 2 over 3. Is that the same thing as 4 over 6?
Yes.
Yeah.
Is that the same thing as 6 over 9?
Yes.
How do you know?
Because they all.
They all reduce down.
The
They all reduce down to what?
LSD.
2/3. Guess what would happen if you multiply diagonally?
LC.
It'd all be the same.
You get the same numbers when you multiply diagonal. Not, this is 12 and 12. Look, you can do this in your head. 12 and 12, 36 and 36. And then if you went from the first, you would all the way across, you would go 18 and 18. So you kind of do it. If the numbers are easy, I think you guys are smart enough to do it in your head. But, so you would say, yes, they are similar.
Can we do it? Alright.
As long as you write it out, Bill. All right, try the next one. A t-shirt iron-on measures 2 inches by 1 inch. Here's the iron-on. It's 2 by 1. It is enlarged by a scale factor of 3 for the back of the shirt. The second iron-on is enlarged by a scale factor of 2 for the front. I was trying to figure out. So we're gonna do this one by 3, which hopefully you guys can do in your head. Is that 6 by 3? Is that right?
Yeah.
And then the second iron-on is a scale
12 by
factor of
6.
2. So I'm going to multiply this one by 2.
12 by 6.
Double it. 12 by 6. And what are the dimensions of the largest iron-on?
12 by 6.
12 by 6. And are they proportional or are they similar?
Yes.
2 over 1. Does it
Yes.
equal 6 over 3?
Yes.
Does it equal 12 over 6?
Yes.
Yes.
Because they all equal what?
2.
2 over 1 if you reduce them. So that's another way to do it, is you can reduce them down. But notice the whole diagonal thing works. 6, 6, 36, 36, 12, 12. Okay?
Question.
Go ahead.
What does the iron-on say?
Iron on t-shirt.
Rocco.
I don't know.
Says my
There's always funny
Beans.
shirts at those stores like up in Wisconsin at those,
Yeah.
you go to those like t-shirt shops.
God.
There's always good ones in there. So I don't know what it is. All right, now, on the first 3 problems, guys, we've always enlarged it. What happens if your scale factor is less than 1, though?
Then it can be smaller.
We're going to get smaller. All right. Rocco, did you guys know Rocco's a baker?
For real?
Yeah. No, he's not a baker. Rocco the baker is reducing an 8-inch by 10-inch photo to place on the image of a cake. So he's got an 8 by 10. Okay? And he needs to reduce it to put that image on a cake. He's a nice baker. Okay? He reduces it by a scale factor of 0.8. Does everybody agree that 0.8 is less than 1?
Yes.
So we're going to make it smaller. So you can use your calculator to multiply by 0.8. Is that like getting a lot smaller or a little smaller?
Little.
Just a little small. 0.8.
6.4 is 8.
Then he decides that image is still too large. So he's going to reduce it again by a scale factor of 0.9. So whatever you get as your second one, you're going to multiply by 0.9 and make it even smaller. Did anybody multiply those numbers by 0.8 yet?
6
I
by
did.
point-
And then
or
you
6
get,
by
and then you get
6.4 by 8.
6.4, very good, by 8.
And then you get 5.76. Or 6.4.
Hold on, 6.4, by 8.
5.76.
and then multiply by 0.9, you should get 7.2. And then what's 0.9 times 6.4?
5.76.
5.76. Okay.
Round that to 5.8.
I think it doesn't say to round anywhere, and since it works out to 2 decimal spots, just leave them. Very good question. Always read the directions and see if it says to round. So, what are the dimensions of the final image?
7.2 by 5.76.
5.76. Okay. And are they similar?
Yes.
Here we 10 over 8. Does that equal 8 over 6.4? Okay. And then does that equal 7. Doing the big one, 7.2 over 5.76. Another way you guys can do this is you can just divide all three of them and see if you get the same decimal number. Divide 10 by 8. 8 by 6.4, 7.2 by 5.76. You would always get the same number. Yes, they are similar. So it looks like you have two things to be doing for each problem. Finding the dimensions after making it bigger or smaller, given a scale factor, then decide if it's proportional. I think they're all going to be proportional. I can't think of an example where they're not.